All right, I just want to take this video to sort of give an introduction or a beginning understanding to the idea of the difference between examining proportions in research versus examining means, because we're going to see this over and over again, at least three times, if not six or seven times, where we do a statistical procedure and we do it to a proportion. And then we do basically the same exact thing, but we do it to a mean. And I feel like if you don't have this initial introduction to the difference between proportions and means, you might get lost in the shuffle. And then, I even had a student one time that said, we learned how to do it on a proportion one day, and then we learned how to do it on a mean on another day. And the student said, "This looks exactly like we did last time. How is this different?" And I said, "Well, the other day when we did it to a proportion, and today we're doing it to a mean." And I realized that she didn't really understand that there was a difference between a proportion P and a mean mu. So that's what I want to do in this video. Okay. So suppose we want to better understand the heights of high school students, and we want to use statistics to understand the heights of high school students, okay? Well, there's two ways that we could go about doing this. So one way we could do this is we could choose a specific height, like 68 inches. Then measure, get a tape measure or something and walk around and measure a bunch of students. We'll measure a sample. That means not all of them, just some of them. Measure a sample of high school students, maybe let's say 143 of them. We call that N, the sample size. And then simply just count how many of the 143 are 68 inches or taller. So if they're 68 inches tall or taller than 68 inches, then we include them. We call that a success. Okay, so we call it a success. If they meet a certain criteria, we call it a success. And suppose that about 58 of the 143 all are 68 inches tall or taller. Then we would say that P hat, this symbol right here is sometimes called hat, is equal to the proportion or the fraction 58 divided by 143. And if you were to plug this into a calculator, you would get 0.406. That's rounded to 3 decimal places, okay? So then 0.406 of the students are 68 inches tall or taller. This is called a proportion. So this P right here stands for the word proportion, okay? The hat means that it's from a sample, but we'll talk about that in just a few minutes, okay? So this is called a proportion. It is simply the fraction of the number of units in a sample that successfully meet a requirement, which we often called X. So X is the number of successes divided by the total number of units examined, which is N, or the sample size, and then converted into a decimal. So the proportion, the sample proportion, P hat, is equal to X, the number of successes, divided by N, the sample size, and then converted into a decimal. Another way to do this, would be to measure, let's say, again, 143 high school students, but to measure their heights just like we did before in inches, just like we did before, but this time, instead of just marking which ones were 68 inches or taller and which ones were less than 68 inches, this time we sum up. This symbol means a sum. We sum up all of the measures. And suppose that when we add up the heights of all 143 students, let's say that the sum is 9,324. And then we divide by the N equals 143. So we add up. You already know about this. This is an average, but we call it a mean. You add up all of the students' heights and then divide by how many students you measured. And we call this X bar, or the sample mean. And x bar in this case would be equal to the sum of all of the heights that were measured divided by the sample size. So 9,324 divided by 143 would be 65.203 inches. And so a mean is a number that is akin to the thing that we're measuring, okay? Whereas a proportion always winds up being a number between 0 and 1. So a proportion can only be as small as 0, and a proportion can only be as large as 1. But a mean is usually a number that's very similar to the actual variable that you are measuring. Now, suppose we identify the number of high school students that are 68 inches or taller. And when I say the number, I mean out of all of the high school students. Now, all of the high school students, that's a population. And if we were to measure out of all of the high school students in all of existence that are 68 inches tall or taller, we would have what is called the population proportion, which is just the letter P. Notice there is no hat on this one. It's just the letter P. And so the population proportion, P, would be equal to all of the high school students in all of existence, their heights, or the ones that are, 68 inches tall or taller, divided by the total number of high school students in all of existence. We sometimes call this the true proportion. Now, usually we cannot know the true proportion P, okay? And so what we usually do is we use a sample proportion P hat to estimate or to guess the true proportion. And as stated earlier, P hat, the sample proportion, is equal to x over n, which is the number of successes from the sample divided by the sample size. Similarly, if we measure the heights of every single high school student, which we would say, we use the letter x to represent each measure, and sub I would be each one. So x sub 1 would be the first high school student, x sub 2 would be the second high school student, x sub 4,543,897, etc., okay? And then, so this is every single high school student. If we measure the height of every single high school student in all of existence, and then add up all of the heights, and then divide by the total number of all existing high school students, which we would call the population size n, we would have the population mean mu, which is, we pronounce it mu, it's a Greek letter, mu, and we would have the population parameter mu is equal to the sum of the heights of all high school students divided by the population size of all high school students. However, just like with proportions, we usually cannot know the population mean mu of a variable, usually for varying reasons, usually because it's too expensive or too difficult to measure everybody. So we use a sample mean x bar to estimate or guess the true population mean. And as stated earlier, the sample mean x bar is equal to the sum of all the measures from the sample divided by the sample size. Okay, so hopefully this video has helped you better understand the difference between estimating a proportion from a population versus estimating the mean from a population.